Hey guys, so this is a review for exam 2 of Math 094. Starting in section 2.4, we covered 2.1 and 2.3, but 2.1 was just kind of graphing ordered pair, and 2.3 was graphing lines by plugging points, and so as we've gotten farther into the chapter, we have better ways to do that. And so I'm going to approach graphing as either slope and intercept or just intercepts, depending on what kind of problem we're presented with. So starting in 2.4, this is where we got intercepts, and the basic deal with intercepts is one of the coordinates 0. So if we're looking at a y-intercept, then the x-coordinate's 0. If we're looking at the x-intercept, the y-coordinate's 0. And so to find those, we just basically let the opposite coordinate be 0. And so for me, I always just kind of think of it as I'm going to set up an xy chart. You'll let x equals 0 find y, and you'll let y equals 0 find x. And that's basically this chapter, or this section. So let me show you some examples with that. Okay, so this first question, we are in standard form, so our x and y are on the same side. And to me, the best way to do this one is actually the intercepts. And so even if the directions didn't say graph by intercepts, this is how I would do it. And so what we're going to do is we're going to find our x-intercept first, so we'll let y equals 0. So that would look like 3x minus 4 times 0 equals negative 12. So what happens is this piece just drops out. So I think of it as just kind of covering it up with my finger and going, okay, so 3x equals negative 12. Divide the 3 over and you get x equals negative 4. So that's going to be my x-intercept. And then for my y-intercept, I let x equal 0. So if I cover that up, I'm left with negative 4y equals negative 12. And like I said, that's kind of a nice way of looking at it. Divide the negative 4 over, and you get y equals, and that becomes positive 3 because of the double negative. And let's see, trade pens here. So then graphing these, we get negative 4, 0, so when x is negative 4, y is 0, and we get 0, 3. X is 0, y is 3. And so we get a line that looks kind of something like that. For this next one, the intercepts probably aren't how I would graph it. The y-intercept's great because this is in slope-intercept form. We didn't quite know y equals mx plus b when we did this before, but now we can just look at this and know our y-intercept is negative 3. We can also let x equal 0, and we're left with y equals negative 3. And so, kind of regardless, I would use that point for graphing. For me, if I got to just graph this, I'd go over 2 and up 1 and use my slope. But if it's asking for the x and y intercepts specifically, then we need to actually go find the x-intercept. So I'll let y equal 0, and then solve for x. So I'm going to add my 3 over to this side. And then since I have that 1/2 there, I'm going to multiply both sides by 2. And then that's going to cancel, leaving me 6 equals x, where the x-intercept is 6. And so that would be right there. And you can see if I just kept going over 2, up 1, over 2, up 1, I would have got there using the slope. I kind of missed the point when I drew the line, but I was aiming for that. And so, like I said, not probably the best way just for graphing, but if you have to find the x-intercept, that's how you would do it. Okay, this one gets missed a lot on the test. So the intercept on this isn't there. There's nothing on the end, so it's just 0. Because if I let x equals 0, y equals 0. So that got me, that's funny. Let me try that again. X, y. So when x is 0, y is 0. So I could just pick an easy point like 1. If x is 1, then negative 2 times 1 is negative 2, and the y equals negative 2. So I could get there that way. So I got 0, 0, 1, negative 2. So that would make my line kind of look like that. I could think of this, if I want to think of it as 2.5, because we know that now. We could think of this as y equals negative 2 over 1 x. So we could just go right 1 and down 2 and get that same point. But don't let the little easy one get you. And this definitely, this is the too easy it's hard question on the test. This is another too easy that it's hard question on the exam. So this is x equals -4, or x equals 4, pardon me. So what that means is x is always 4. It doesn't matter what y is, x is always going to be 4. And so if I graph that, when x is 4, y is 0. When x is 4, y is 1. You can see 4, 2. I'm going to get a vertical line. So anytime we have something of the form x equals some constant a, it's just going to be a vertical line through that point. So in this case, 4. So my x-intercept would be 4, 0, and then the y-intercept wouldn't exist. Okay, and then this is the last of the too easy, they're hard. So xy, this is saying y is always -1, so it doesn't matter what x is, x can be any value, y is just going to stay -1. So when x is 0, y is -1. When x is 1, -1, 2, -1. So you can see we're getting a horizontal line through y equals -1. And so that would be our intercept. So anytime we have something of the form y equals b, b is that y-intercept, and then we're just going to have a horizontal line through it. And so the ones where it's, y equals or x equals, people, they're easy questions unless you don't remember how to do them, and then you usually don't get very much because it's usually pretty wrong. So they're absolutely on the test, so I would definitely give those a look. And then I'm just going to make one up here, y equals 2/3 x. This also gets people, and so this is kind of like the -2x one. And sometimes I think they just freak out over the fraction, and it's a really easy question. So it's kind of this, the y equals and the x equals that are probably, I think they're 6 points apiece, so 18 points that are, look at it, and it should take you just a second to do, but people lose those points. So for this, the y-intercept isn't there, so it's 0. And again, if x is 0, y is 0. And then just use your slope. So if this is our rise and our run, so we're going to go over 3 and up 2, and then that red line would be it. And I can't tell you how often people miss the, quote-unquote easy question. If it was negative, I'd go over 3, down 2. Your other option, if you don't love the slope version, is if you have an equation like this, pick the denominator, throw that in for x. Because if you do that, these cancel, and then you're left with a nice, easy point to graph it. It's that same 3, 2 that I got by the slope. So there's my little spiel for the again, quote-unquote easy questions. Okay, next section is 2.5, slope of a line. And I've already been kind of referencing this in 2.4 since we've seen it at this point. Just kind of a little reminder of some of the definitions. So slope is vertical change over horizontal change, or easier to remember, rise over run. The slope formula, so I don't generally love memorizing, but this one I'm going to ask you to know for the test. And so there's basically, there's 2 formulas to know. And there's this one, and there's y equals mx plus b. And those are the 2 things that you kind of want to have in your head. If you're a person who has a hard time memorizing, as I am, what I would do is I'd have it on a card. I'd sit there, look at it. And as soon as I get the test, at the top of the test, I'm writing down m equals y2 minus y1, x2 minus x1, and then I just sort of exhale and go, okay, that's there, and I don't have to worry about it. And then when I need it, I can go back and reference it. So if you're worried about forgetting it, just jot those right on the top of the margins of your notes, or of your exam, sorry. So then that was our slope formula. Sorry, I kind of diverged there. In terms of rise and run and a picture, so run is our horizontal change, rise is our vertical change. For me, I always run positive, so I'm always going to the right. If my slope is positive, I go up. If my slope is negative, and then I go down. And then parallel and perpendicular slopes. So for parallel, remember they have the same slope. And then for perpendicular, if you multiply them, then their reciprocals are multiplied to -1. Or sorry, if you multiply the 2 slopes, they make -1, and it's because they're the opposite reciprocals of each other. And I'll show that with an example, it'll be much more clear. Okay, so for this one, we're supposed to find the slope of any line, A parallel, B perpendicular, to the line through the given points. And then I guess you're supposed to graph it, because I put a graph over here, but I didn't actually write graph. So if we're going to find the slope of this, I'll do it both ways. So if we weren't given a graph, I'd have to use the y2, y1, x2, x2, x1 formula. So m would equal y2 minus y1, so negative 5 minus the 3, over x2 minus x1, so 2 minus, and then it's parenthesis negative 4. And that little minus and minus gets people a lot. Up top we're going to have negative 8. Downstairs it looks like 6. And we always want to reduce fractions, so that's going to be negative 4/3 when I cancel the common 2 out of the numerator and denominator. So that means that m equals negative 4/3. And then m and the two little lines mean parallel. So that's also negative 4/3. And then m and perpendiculars and that upside down t. You don't have to know those for the exam, but just as I'm using them. Remember for that, so this was negative, so this will be positive, and we just do the reciprocal. So 3/4. And if I multiply those two together, we get, negative 12 over 12, and that's negative 1. The other way would be, instead of doing this, and we don't always have a graph, and our points don't always fit on a graph, and they're not always nice points, so we do need to have this. But if there is a graph, we could do this also. So negative 4, x is negative 4, y is 3 would be there. And when x is 2, y is negative 5. So that would be there. And then there's the challenge of drawing a straight line, which is a bit of a challenge. So I'm going to cheat and grab that middle point. So if I did that, what I would get is this big triangle. And I could also go down and over, doesn't matter which way I draw it. I just have the habit of going to the right first. So this is 1, 2, 3, 4, 5, 6 boxes. And this will be 2, 4, 6, 8 boxes. We're going down, so that's negative. And then rise over run, that's going to be negative 8 over 6. You can see I'm right back here, and there's our negative 4/3. So a couple of different ways of approaching it, and sort of depending on what we're given, it depends which way I go. Number 7, this is the same thing, so I'll go a little bit quicker on this one. So let's see, m equals 2 minus negative 4 over negative 1, and then minus negative 3. So that is 6 over, let's see, negative 1, and then minus the negatives, this is like negative 1 plus 3. So it's going to be a positive 2, and it looks like my slope is 3. So if my slope is 3, then m parallel is also 3, and then m perpendicular, so that's where you got to remember that there's an invisible, and we don't want to type the 1 under there, but it's helpful in this case to think of it as 3 over 1, because then we can see our perpendicular slope would be opposite signs, so negative and 1/3. And then I could also get there by graphing. So if x is negative 3, y is negative 4, and when x is negative 1, y is 2. And so if I can draw a straight line, looks kind of like that. And within the limits of my drawing here, I guess I should draw the big triangle. So that would be 2 and 6 for the rise and the run, and then 6 over 2 makes our 3 again. So could have gotten there that way also. Okay, so then we have graphing based on the slope and the y-intercept. So given the slope is negative 4, so that's going to be the same thing as negative 4 over 1. And b is 1, so I'll just start right here. And then we have rise and run. And so we're going to run 1 and then rise negative 4. And again, you can go negative 4 and 1 if that seems more natural to you. It seems like I'm the only person who wants to do the horizontal first. So if the vertical seems better, do that. And then our graph would look something like that. And then for number 9, we have b is negative 2. So that would be right here. And then our slope is 1/3. So 1/3. So rise of 1, run of 3. And I'll kind of go over and down just to get that other point in the right spot. And that would be our graph. So there's our 3 and our 1. So these are basically the same thing, except now we're given an equation instead of the m and the b. Easy enough to find it since these are in slope-intercept form. So m in this case is -5/3, right? It's what's in front of x, because this is y equals mx plus b, and b is the thing on the end, so b would be 2. And then graphing, we're going to start from 2, and we're going to run 3, and we're going to rise -5. So 2, 3, 4, 5. And I think we get something that looks about like that. And then for number 11, m in this case, that floating negative, that's a -1, right? And then b is -4. So starting from -4, and we're just going to go over 1, down 1, because we can think of this as -1/1. So right 1, down 1. Right 1, down 1. So it should look about like that. Okay, and this is just kind of a little recap of the equations we've seen for lines. Slope-intercept form, so that's one that you do definitely want to know and know what the pieces are doing. So that's our y equals mx plus b, and m is our slope, and b is the y-intercept. Standard form, so that's the one where the x and the y are on the same side. And so you don't have to know the name of that. You can see things in that form, and this is where it's easier to graph from intercepts. But this just kind of remind you that's the name of that. Point slope form. This one, it's another way of finding the equation of a line. I think I did it during the section. I usually use y equals mx plus b when people are first learning this, just to kind of have one version of it. This and the slope formula are actually the same thing, but this you definitely don't need to worry about so much on the exam. Again, it's sort of an alternative method of this. There's places where I like using this, but people have a hard enough time with this question that I just try to show the same version and not make it feel like it's something different. And then slope of line, that's the other one you should know that we just looked at from section 2.5, and that's our change in y over our change in x. So number 12, give the slope and y-intercept for each of the following equations. Sketch a graph. Give the slope of any line perpendicular to the given line. Okay, so our slope is right there. It's 4/3. Our y-intercept is 2. And then m perpendicular, there's a little t there, upside down t. So that would be -3/4. So opposite and reciprocal. And then we're supposed to graph our original line. So b is 2, we'll start there, and we're going to run 3 and rise 4. And that would be our line. For this one, we're supposed to use the graph to find m and b and then write the equation. So right there, that is b, that's our y-intercept. So that's -1. And then if from there I go over, I'm aiming for that point because it's what's sort of intersecting it, where the grid meets. So it looks like it goes over 3 and then down 1. So rise over run, so that would be -1/3. And then our equation is going to be y equals -1/3 x minus 1. Number 14, we have, for the following problem, the slope in one point is given. Find the equation of the line, write your answer in slope-intercept form, and then graph. So, graphing, and let me point out here, because I think I do this on the exam too, you don't even need the equation to graph this. And what's kind of nice about graphing it this way is that when you do solve your equation, you kind of have a double check with the graph. So if x is 4, 1, 2, 3, 4, y is -1. And then this has a slope of -3/2. So it's going to run 2 and drop 3. So I could go backwards 2 and up 3, backwards 2 and up 3. And right there, if you do a good job of drawing that line, and assuming this isn't fractional, that's your equation. So it's going to turn out to be y equals negative 3 halves x, and this is 1, 2, 3, 4, 5, plus 5. If you don't have a graph, then you can't do that, and so let me show you how to do it the other way. And this other thing is also going to be kind of every single problem in the section, so we can't always get there by graphing. But given a point and a slope, you can graph it, and that's going to show you where your y-intercept should land. Getting there the other direction, algebraically, y equals mx plus b. And right here we have, this is our m, this is our x, and this is our y. And so I'm just going to plug them in here and then solve. So y is negative 1, m is negative 3 halves, x is 4, and then plus b. And so this is going to go negative 1. You can cancel right here, or if you're more comfortable, you can go, think of this as over 1, so then that makes it 3 and 4 for negative 12 halves, plus b. Simplifying, I would get negative 1 equals negative 6 plus b, and adding over the 6, I get 5 equals b. That's exactly what I got based on my graph. So from here, I would just go y equals, there's my m, x, and then my b. So if you have a graph, it's a pretty nice way to get there, but this is going to work more generally in more cases. So this is absolutely what we're trying to get out of the section. Okay, so for this one, we're given 2 points and then still trying to find the equation, and then no graph. So to find the equation of a line, I need 2 things. I need a slope and I need a point. And right now I got 2 points. So given 2 points, I can do m equals 4 minus 1, so 4 minus 1, and then over 2 minus negative 4. And it's going to be 3 over 6, also known as 1/2. So now I have my slope, and I can use either of these points. I'm going to use the one without the negative sign. And I'm just doing what I just did in the last example. Oops, that's supposed to be an m, x plus b. So I'm just going to put y in is 4, m is 1/2, x is 2, and then plus b. And then this time I'll show this as a cancel, so I'm just going to cancel out those 2's. I get 4 equals 1 plus b, and then scoot the 1 over, and that will be 3 equals b. So my answer, make sure to remember to write down the answer, y equals 1/2, that was my slope, x, and then plus my y-intercept, b. Okay, number 16 is find the equation of a line parallel to this graph that contains that point. And so, again, you just got to remember you need 2 things to find the equation of a line. You need a point, you need the slope. We got our point, that's going to be our xy. And that means my slope must be coming from this. So negative 2x plus y equals 7. If I add this 2x over and solve for y, those cancel, and I'm left with y equals 2x plus 7. And so then that means m is this 2 right here, because now I'm in slope-intercept form. And so now I got a slope right there, and I got a point up here. Put those together, and then that gets me my equation. So again, y equals mx plus b, and y is negative 4, m is 2, x is 1, plus b. And so this is negative 4 equals 2 plus b, add the 2, or sorry, subtract the 2 over, and get negative 6 equals b. So this will be y equals, m is 2x minus 6. So I was thinking about it a little bit, and I thought, I should at least do one example using point slope form. And so you don't need to know this for the test. This is kind of how I've been doing them all. This is another way to get there, and you can run into this, so I feel like I should at least do this for exposure. So this is going to be now kind of my x1 and my y1, sorry. So y minus 4, just minus a negative 4, tossing that in there. M is 2, and then x minus 1. So if I clean this up, y minus a negative 4 is y plus 4 equals, I'll distribute that 2x minus 2, and then subtracting the 4 over, I get y equals 2x minus 6. So I get the same exact thing. People have a harder time remembering this formula, and they tend to remember this one because it just comes up so much. So you can do this either way, though. So I just wanted to do one example where I showed the other version. Okay, so this is similar to the last question, except now it's perpendicular to this line. And so we'll go negative x plus 3y equals 1. So I'll add that x over. I'm solving for y, so I can see what my slope is. And those cancel, leaving me 3y. And then plus x and plus 1 is just going to be x plus 1. And then I need to get this 3 out of here, so I'm just going to divide. So I'm dividing everything by 3. Canceling there. Y equals, looks weird this way, so this is like an invisible 1 on that x, so I'm going to write it 1/3 x, because it looks a little nicer, but they're the exact same deal, plus a third. So m is 1/3, which means m perpendicular is negative 3. So that's what I'm going to need to use with that point right there to get my equation. So y equals mx plus b, and let's see, we know that y is negative 2, m is negative 3, and x is 1. So negative 2 equals negative 3 plus b, adding the 3 over, and 1 equals b. So final answer would be y equals negative 3x plus 1. And so this one definitely got a little bit more involved, but it all comes down to you need to find a slope and you need a point. You're pretty much always given the point. Sometimes you have to work a little bit for the slope, but realize that's your step. That's what you're looking for. Because once you have the slope and the point, it's the same operation over and over. Okay, section 2.7. So this was the linear inequalities, this time in two variables. So this is where we had to shade one side of the graph or the other. Our steps for working these out is, first, we just kind of think of it as an equal sign rather than an inequality, because we just got to get the boundary drawn. And then 2 is we graph the boundary. So if it has an equals, we use a solid line. If there's no equals, that was the dashed line. And then the third step is to get it shaded. So that's where we use 0, 0 if it's available, and it pretty much generally is. The only time it wouldn't be is if the line went through the origin. But we plug 0, 0 in the original equation. If it comes up true, we shade 0, 0. If it comes up false, then we shade opposite 0, 0. So let me show that with some examples. Okay, so for this first one, we are in standard form, and so I would do intercepts. So if x is 0, then that piece is gone. Negative 6 equals 12, and so then that would be, y would be negative 2. And if y equals 0, then that piece is gone, and we have 2x equals 12 or x equals 6. And there's other ways of doing that, but that is by far the easiest. So x is 0, y is negative 2, and then I think 6 is right there. And no equals, so I'm going to do a dashed line. I amazingly remembered. And then I'm going to test 0, 0. So if I put in 0, 0, I get 0 minus 0 is greater than 12. 0 is not greater than 12. So 0, 0 failed, so I want to shade opposite 0, 0. So that would be down there. Number 19, this one is in slope intercepts, so I'm going to use the slope and the intercept. I got an intercept at 3, And my slope is negative 2/5, so I'm going to count over 1, 2, 3, 4, 5, and then down 2. And this one has an equal, so I'll use a solid line. So something about like that. And then if I toss in 0, 0, 2/5 times 0 plus 3, so 0, and you can just 0 and cover that up. I'm just kind of showing it. 0 is less than 3. And 0 is less than or equal to 3. So that one is true. This one was false. So when it's true, we shade the side with 0, 0. So this worked, so everything over here is going to work. 3.1 through 3.3, this is where we had the two variable systems of equations, and we had 3 methods for solving them. And we also had 3 outcomes, so I'll show those as we run into them. Our first method for solving was graphing. So for this first equation, y equals negative 2x plus 2. So I'm just going to start here at plus 2, and then my slope is negative 2. So it's going to go over 1, down 1. Over 1, down 2. And this is where you need to draw a really straight line. So I'm just going to keep following this over 1, down 2, so that I kind of get all my points where they should be. And I'll try to draw a straight line. Not too bad. And then let's see. This next one, my intercept is at negative 5. So 1, 2, 3, 4, 5. And my slope is 1/3. So it's going to run 3 and up 1. So you can see our point of intersection right there. And it looks like that point is x is 3 and y is negative 4. Okay, so next up we have the elimination method. And this is where we multiply one or both of the equations by some constant. In order to get what we want is to have the same coefficients but opposite signs so that we add them together. Remember, one of those variables drops out and we're left with something with one variable that we can solve. So that's the key to it, is same number, opposite signs on some either x or y. Looking at this first example, the x's would suck because I'd have to make these both 42. So I have to do this by 6 and this by negative 7, and then my number, or by 7, and my numbers would get all big. So much easier to go after the y's. So I'm going to leave equation 1 alone, so I'll just jot that down here. And then we multiply this one by 2, because that's going to give me a positive 2y, negative 2y. So 2 times 6 is going to give me a 12x, 2 times y, and then 2 times 15 gets me 30. And then adding these, negative 7 plus 12 is going to be 5x. The y's cancel out as planned, equals 20. And then dividing, I get x equals 4. Once I have x equals 4, I can back solve. I could pick either equation. I think I'm going to go with the one with the plain y since I'm actually solving for y. So I'll go 6 times 4 plus y equals 15. And then 24 plus y equals 15. And then I'll just subtract the 24 on both sides. And that gets me y equals negative 9. So a solution is 4, negative 9. This next one, so it looks again like if I use a 2, hopefully I didn't make these all be 2. I think I actually did. So, okay, for this next one, it looks like I got, well, you can kind of see what's going to happen is a bunch of stuff's going to cancel out. So I'm going to just take this first equation again, write it down, and it happens to be 2 again just because of the negative 2 and the positive 1. So I'll multiply this by 2, and I get negative 8x plus 2y equals 2 times, I'm doing that, 2 times negative 3 for negative 6. That drops out, leaving me 0 on the left-hand side, and then over here I get 2. So this is one of our two kind of special cases. This came out false. And so when it's false like that, that means it's a no solution. And there's lots of ways of saying no solution. You could also say inconsistent or lines parallel. Those are all correct answers. If you do run into this on the test, and it's very likely on the test because, you know, it's kind of one of the major themes of these sections, make sure don't stop here, because 0 equals -2. You haven't said yet what the answer is, and the answer is that there's no answers. So make sure to make clear that you know what that means and get that down. And then the same kind of thing with the infinite solution ones. Okay, and then these next two are solved by substitution. So since this is y equals this stuff right here, I'm just going to take that and drop it right there for that y. And then that's going to give me an equation in just x. So -2x minus, and siren. Cool, let that go by. So -2x, and then minus this piece. So make sure to open a parenthesis right there. And then that's going to equal 9. And so now this is all in terms of x, so I can solve it. So I'll clean up the parentheses. Minus and minus makes a plus 3x. And then minus and minus makes a plus 14 equals 9. So down 2x plus 3x, so that's x plus 14 equals 9. And then just kick the 14 over to the other side. And we get x equals -5. And then same thing, I'll just use this to back solve, so I'm going to put it in this first equation since it's already solved for y. So y equals -3 times -5 minus 14. So y equals 15 minus 14, which makes 1. So -5 and then 1. Number 24, so now we have y equals again. And so this is going to go in for that y. And that's going to look like -4x minus 2, and then minus 2x plus 6 equals -12. You can probably see where this is going. -4x minus 2 times minus 2 is going to make that a plus 4x. And then -12 equals -12. And then those drop out. -4 plus 4 cancel. And I'm left with -12 equals -12. So this is one of the true statement. And so when they come out true, that's when it's going to be infinite solutions. And again, don't leave it here, because -12 equals -12 isn't really an answer. It doesn't say what it is. So make sure you do infinite solutions. If it's, you could also do lines coincide. I think we saw that terminology. Or dependent is the other word for it. And sort of on that, I am a terrible speller, and so if infinite is one of those words that you have trouble with, it's totally okay. Get something down that's kind of close to it, and I will know what you mean, and it will be all good. Okay, and so we have arrived at the dreaded 3.4. So this is where we got 3 equations, 3 unknowns. We picked up z. So remember, the deal with this is we take 2 equations, we eliminate a variable. And then we take a different pair of equations and we eliminate the same variable. Let me say it one more time, because that's really the key to getting through this. So we pick two equations, doesn't matter which ones, and we eliminate some variable. And then we pick a different pair. It's going to use one of the equations again, but it has to be a different pair. But we stick with the same variable. If you eliminate different variables, you have 2 equations that don't match and you're stuck. So have to stick with the same variable. So when I solved 25, I had decided I would get rid of z's just because this minus z plus z seems so easy. And you know, the x's or the y's aren't terrible choices on this either. I just thought the z looked easiest. So I'm going to go equation 1 plus equation 2. So 2x plus y minus z equals -3. Negative x plus 2y plus z equals 5. And adding those, I'm going to get x plus 3y, z's cancel, equal 2. And then this is what I've been referring to as equation 4. And now I have to pick, I've used 1 and 2, so I can either do 1 and 3 or 2 and 3. I'm going to pick 2 and 3 just because I have to eliminate this negative 2, so I like that that's a positive z. So I'm going to go 2 times equation 2, and then I'll add to that equation 3. So I'm picking a different pair, but eliminating the same variable. So that's going to go negative 2x, 2 times 2 plus 4y plus 2z. 2 times 5 is 10. And just copy down equation 3. And then let's see. Oh, that's kind of cool. So in this case, we kind of got a bonus cancel. So the x's cancel out, and then we get 7y. The z's cancel out, and I get 7. And so if that happens, and if that had happened on my first try, I come over here and now I have y equals 1, and I'm like, what do I do? What you would do is you would make another equation so that you can plug that in and then get your second variable. And you'll see on the next example when I do that, we're going to get an equation 5, and then we're going to have to solve that system. But this one's being friendly. So since I got y equals 1, I'll put it back here into 4. And this does sometimes happen, and then it sucks because sometimes this will happen on the very first step, and then they're stuck. But all you gotta do is make your second equation, plug it in. So then I have x plus 3 times 1 equals 2. So x plus 3 equals 2. So subtracting 3 on both sides, I get x equals negative 1. And then I'll just come back to the first equation because I'm looking for z. Yeah, that one's fine. So 2 times negative 1 plus 1 minus z equals negative 3. So that's going to go negative 2 plus 1 minus z equals negative 3. That's negative 1 minus z makes negative 3. Add that over. Try to keep all the signs straight. Negative 2, and it looks like z should be 2. So solution is negative 1, 1, and oops, we'll make that into a 2. Okay, this one's another example of kind of the same thing. I went with eliminating y's just because I had that easy plus minus for one of them, and then I can do a 3 or a negative 3 here and use that to eliminate with equation 2. And it just seemed a little bit easier than the x's and the z's. But again, any letters right, just try to pick the one that looks like the least amount of math. So I'm going to go 1 and 3. And then this one. And I'll just add them together. So 6x, y's drop out, plus 8z equals negative 4. And then, so then I'm going to do, let's see, I'm going to go, I think 3 times equation 1, and I'll add that to equation 2. And you see that'll get me a negative 3y here and a plus 3y here. So 3 times 2 get me 6x minus 3y, and that's going to be 15z equals negative 6, and then just copy down the second equation. And let's see, adding those, oops, this is a 6. Oops, I just realized I just copied down. Sorry, I'm going to scratch that. And I just realized I grabbed half of one and half the other, I think. So let me do this right. So x plus 3y minus z equals 6. So there's equation 2. So 7x, and then 3y's cancel, plus 14z minus 6 plus 6 makes 0. And so there's a few different ways to do this. This is going to be, sorry, this was my equation 4, And this is my equation 5. That's kind of my mess in the middle. I'm going to do it the way that you guys probably would do this. You know, that way is in the notes. Yeah, let me show you the way you would probably do this. So, given 6 and 7 and 8 and 14, I went with 6 and 7 in the notes. So I'm going to make these both in the 42. So I'm going to go negative 7 times 4. And that's going to be negative 7 times 6 is, and this is equation 4, negative 42. And then x, negative 7 times 8, negative 56z, negative 7 times negative 4 makes 28. And then I'm going to go 6 times this one. And so what I'm doing is I'm making a negative 42 and a positive 42. So that'll be positive 42x. 6 times 14 is 84z, and then 6 times 0 is still 0. So those cancel out. Negative 56 plus 84 is 28z equals 28, and then z equals 1. So that's kind of a more classic solve where we get an equation 4 and 5, and then we put those two together and eliminate a variable again. So basically right here we're right back in sections 3.2, the elimination with two variables. Once I have z as 1, I can come back to either of these equations. The thing that I was going to point out that would be a really easy way to do this problem, and it's not necessarily something you would see to do, and so that's why, you know, I'm hesitant to show this example that way. But this 7 and 14, they have 7s in common. So I could absolutely divide that out, and that would get me x plus 2z equals 0, or x equals negative 2z. And then I could just plunk that right in for x, and then get there that way also. And this, you know, had a little bit bigger numbers and maybe some room for error. But this is a nice way to look at this. I could also have made this equation a little smaller. I could reduce this to this. I could reduce this by 2 and got 3x 4z equals negative 2, and then solved with a little bit smaller numbers. So a couple kind of alternate things that I see, in particular with this set of 4 and 5, but that's probably the way that you would end up doing it, just as you're learning this method. So let me come back here to my mess again. So there's my equation 5. I'm going to plug z in, so I got 7x plus 14 times 1 equals 0, 7x equals negative 14, and then x equals negative 2. So there's my first solution, my second solution, and then I'm going to come back to equation, I think I'll do 2, just because it looks relatively simple to plug into. So then this is going to go negative 2 for that x, plus 3y right there, minus z, so minus 1, equals 6. So 3y minus 3 equals 6. 3y, adding this over would make 9. And we get y equals 3. So solution is negative 2, 3, and 1. Okay, and then the last section is 3.7. And these are those application problems. So this first one is kind of the odd man out of the problems. The rest of them are all actually the same problem, just sort of in disguise. But you set up the same two basic equations for all of them. And so kind of once you see that, the section does get a little bit easier. That said, this is sort of the odd one. So one number is 3 less than 4 times another. So I'm going to say x is equals 3 less than 4 times some other number, which I'll call y. So 4 times y, and then 3 less than that. And the English is just backwards the math, and it is what it is. Their sum is 52. Okay, so x plus y equals 52, and then find the two numbers. So this one, and while substitution is kind of the lesser used of the methods, this is a pretty good place for it because it's already set up for it. So I'm just going to take this and toss it in for that x. So that will be 4y minus 3 for the x plus y equals 52. So 4y and y is 5y minus 3 equals 52. I'm going to add the 3 over. And that's going to give me 5y equals 55. And then dividing the 5, I get y equals 11. And then once I have that, that's my cat Squawk, and he's squawking. So once we have y equals 11, I can toss it in either of these equations. X plus 11 equals 52. Subtract the 11 over, and x equals 41. And then that's my two numbers. Hi, Squawk. Okay, so this next one goes, Malcolm has 45 coins with a total value of $5.65. The coins are nickels and quarters. How many of each kind of coin does he have? Okay, so he's got 45 coins, so that's going to be nickels plus quarters equals 45. And so for all these ones that are remaining, we're going to have kind of this easy equation that's thing plus thing makes the total things. And then there's going to be a scaled equation. And in this case, the scale is money. It's the value of the coin. So nickels are worth 5 cents. And then quarters are worth 25 cents. So I'm going to say 5 cents times each nickel, and then 25 cents for each quarter. And then that's going to make the $5.65. But since I'm not using decimals on this side, remember we got to not use decimals on that side. And then the way that I always solve basically all of these is you're going to have two numbers here. I multiply by the smaller one, unless there's some like unpleasant decimal, and then I'd use the bigger one. I use the smaller one so then everything comes out positive. I don't have to pay attention to signs quite so much. I really should be good and write it like this, but I'm really bad about that. So I'm just going to multiply both sides by the -5. Slide over this way with it. So I got -5n minus 5q equals -225. And then just copy this one over. And those drop out, which was the plan. And I got 20q equals 340. And then we'll just divide the 20 on both sides. And that cancels, and we got for quarters 17. And then since nickels plus quarters is 45, I can just say nickels plus 17 makes 45. And then we can subtract the 17 over. And that's going to get me nickels is 28. Okay, Jane invested money in 2 accounts. His total investment was $20,000. If one account pays 7%, the other pays 4%. How much does he have in each account if you earn a total of $1,160 in interest? So Jane invested money in 2 accounts, and the total invested was 20 grand. So that's our easy equation. X amount of money plus Y amount of money makes $20,000. And then the second equation, the scaled one, that's going to be with the interest. So one account's 4%, next account's 7%, and so 4% of the money in X and 7% of the money in Y is going to make the total interest for the year. And notice I moved the decimal 2 places, right? Because to do math, we got to change percents to decimals. I guess that was this one. And so this is our 1,160. So kind of going with my, I just like to multiply by the smaller of these two numbers so that these stay positive. I'm just going to go negative 0.04. And so this is multiplication. And that's going to give us negative 0.04x and then minus 0.04y. And that's going to equal, what is it, negative 800. and then just writing this one down. And those cancel, and then this is going to be 0.03y, and that's going to equal 360. And if I had done this, the 7 as the negative, it just means both of these would be negative, and I'd have to be careful to not lose the sign. So that's the only reason I do it, what I do. And then we divide over this 0.03 on both sides. And that's going to leave me with y equals 12,000. And if you remember back at the beginning, we had 20,000 invested, so that means x must equal 8,000. And you can just put the 12,000 right there and subtract it over. Okay, this one's the dreaded mixture problem. It's really similar to the interest problem. So this one's a mixture of 8% solution is to be made from 3 and 10% solutions. How much of each solution should be used if 84 gallons of 8% solution are needed? So I'm making 84 gallons of whatever this stuff is. So I'm going to have some amount of x, some amount of y, and that's going to make 84 gallons. And then these are 3 and 10% solutions. So 0.03, I'll just assign that one to x. I'll do the 10% with y. 0.1. I could do that. I'm going to write it 10 just so it looks more like 10% to you guys. And then that's going to equal, and here's what everyone forgets. They do it's going to equal 8%. And they write down the 8%, but they don't do 8% of anything. It's got to be 8% of the total. You can't have a kind of floating percentage. It needs to be a percentage of something, which is the 84. So this 84 gallons is supposed to be 8% concentration. So that's where we're doing that. And this is going to be our concentration from X and the contribute. Sorry, this will be our contributed. Bleh. So 3% of X and then 10% of Y is this concentration, and that's going to make 8% of our total mixture. So then I will do negative 0.03 on both sides. And so I'm just going to write that underneath this time. So this is going to be negative 0.03x. Same thing here, negative 0.03y. And multiplying those, I get, what is that? That is negative 2.52. And actually, I do need to rewrite this. Because I need to do that little multiply. So here's this one underneath it. Let's try to be lazy. It didn't work out. And then 84 times this is going to be 6.72. So then I'll add these two together. X's drop out as planned. 0.10 minus 0.3 would be 0.07y. And that equals the difference of those is 4.20. And then we can divide over the 0.7. And we get y equals 60. And since we're making 84 gallons of this, if I go 84 minus 60, then that leaves 24 for x. Okay, and then last one. So for Saturday matinee, adult tickets cost $9.50. Kid tickets are $6. 94 tickets are sold for a total of $809. How many tickets were adults and how many were kids? So we'll do our easy one where adults plus kids equals 94 tickets. And then kids were $6. So I'll do 6 times, oops, 950 times the adults plus $6 times kids equals for a total of $809. And so then I'm going to go and I'm going to multiply this one by negative 6. So that's going to look like minus 6a minus 6k equals negative 564. And I'll just bring this one over. 9.50a plus, I'll just write this as a 6 this time, 809. It looks a little different from the notes, but it's the same math. So those drop out, and then this is going to be 3.5a equals 245, and then I can divide over the 3.5. So that leaves us a equals, if you do that in the calculator, you'll get 70. And there were a total of 94 tickets, so that means that K, the kids, must have been 24. Okay, and that wraps up the Exam 2 review.